So, hello everyone, and today we're going to have Chen Liu, and she's going to talk about faculty and faithfulness in NLP.
Hello everyone, I'm Chen. I'm from Computer Science Department, and I'm doing NLP for my research. This is not my research area actually. I'm doing basically text simplification and text summarization, but this faculty and faithfulness is a really important part in both simplification and summarization, and I'm recently looking into this topic, so that's why I'm also kind of delivering this tutorial presentation. And if you're interested, you can always contact me if you're interested in this topic or interested in text summarization, simplification, or just NLP in general. Please keep in touch. Okay, so let's start with the introduction of what is factuality and faithfulness. So these two words, it's fun, the point is really fun. These two words look really similar, but they are different in NLP. Factuality means factual correctness, which is more related to the real world facts. However, faithfulness is more related to the input source. So take this example. We can see, we all know that the capital of France is Paris. However, if right now I'm telling the model that, hey, you do know that the capital of France is actually London, and ask the model to interact with me after that. If the model respond me as following what I told him that the capital of France is London, then he is faithfully correct. However, that is not factually correct. So factual consistency and factuality also called factual correctness, and faithfulness is also called factual consistency. As you can probably tell from the naming, consistency basically means being consistent with the input source knowledge, and correctness is just correct objectively. And factual consistency is always important in those tasks like text summarization, machine translation, data to text generation, because in those texts, we want our knowledge, we want our output to be consistent with the input knowledge. However, in tasks like story generation, so if we are writing a story and we want large language models to rewrite a story for us or continue writing the story for us, that's story generation, or fake news detection, visual storytelling. For this task, factual correctness, which is factuality, is very important. So that's, and we have this knowledge graph, which is kind of not part of the classic traditional NLP task, but also very factual correctness is very important for it. And why do they matter? Why do we care about those two matters? They are critical for applications in healthcare, law, and education, because we don't want any misinformation in these important areas. And yeah, it can increase reliance on the LLM, large language model, which we are using daily now. So yeah, as I introduced, difference between factuality and faithfulness is that factuality is more like real world correctness, and faithfulness is more subjective, is dependent on the input alignment. Evaluation for factuality and faithfulness. Oh, also please stop me at any time if you got confused at any point, because it's my first time delivering this to math department, and I'm afraid of not explaining the definitions well. So we have this traditional metrics called Roche and Blue. They are basically based on the token level overlaps. They evaluate the token level overlaps between the reference text and the output text. And we have some factuality consistent metrics that designed specifically for factuality measurement, like this FactCC. This is to use some entailment-based language model to detect if the output have some relationship with the input, if they are correctly connected. And we have this very interesting method called, it's based on question answering. It's called QAGS, question answering and generation scores. So this method is, firstly, it will generate a question from the input or the output. So so this is example taken from the summarization task, where we have an original text and a summary. which is the output we want. So in this task, we would generate the question based on, we can either choose to generate based on summary or original text, but in this figure it was generated based on summary. So we would have a model generating the questions based on summary. So in this case, it generated the question like, who scored the first season, who was this and that, basically asking the information from the summary. And then two versions of answers will be generated. One version is from the original text, the source text, and the other version of the answer will be generated by summary. And then we will look at the answer generated by text and summary and compare if they are aligned. And if they are, that means the factuality is persisted. But yeah, this method is called the QHS, pretty interesting. And we also have some semantic similarity metrics like BERT score. It's a very famous score based on the model BERT. If you guys know something about the NLP, it's a transformer-based model that was really popular before all the GPTs. And we also have this entailment ratio method, which evaluates the percentage of how the output and input are logically related. And we also have this method called named entity accuracy. So it's based on named entity. Named entity in NLP are things like, for example, we have a sentence here, measures semantic similarity between generated and reference text. So for example, take this sentence example. Reference text is a named entity. It could be it's a noun. First of all, it's a noun, and it is basically the object in this sentence. So that's just an example. Or we have the verb here, which is measure. We have semantic similarity here. So these are all named entities in the sentence. And how we measure the factuality based on this is we track all the named entities in the generated text and the original text, and we check if they align. This is especially useful in the applications like medical text or like law-based text or education text, where we can just, so for example, for a medical text, we just figure out all the maybe medical terms in the original text and the generated text and see if they align. And now we have this very popular word emerging recently, which is called hallucination. I don't know if you guys have heard about it. It's very popular definition about LLM recently. So what are hallucination? Hallucination is very close to the concept I just introduced, to the factuality and faithfulness. Hallucination is a phenomenon where the NLP model generates something that is unsupported, that is fabricated or inaccurate, and they may be related to the input or may not be related. So the key point here is that hallucination refers to those inconsistencies that are only caused by the model itself, rather than external factors like faults in data, like faults in training process. And it is the cause of, it can be a cause of unfaithfulness and the factual inaccuracies. The reason that is so popular recently is because of some incident happened related to the recent LLMs, like I'm gonna introduce them later. So there are two types of hallucination. One type is intrinsic. The other type is extrinsic. So intrinsic is where the model outputs something that conflicts with the original text. And while the extrinsic is where the model outputs something that has never been mentioned before, has never been asked before. So here's an example. We have the original input, the Eiffel Tower is in Paris, and later on in our task like summarization or question answering, the model outputs something like the Eiffel Tower is in Rome. And so this is conflict with the original sentence. That's why we call it intrinsic. However, if the model outputs something like Eiffel Tower is in Paris, which is right, and it was built in 18,000, which is probably also right. I don't know if it's right because I'm bad at history, but even if it's right, it has the extrinsic error because this information was never mentioned. So yeah, And here's the picture I generated using ChatGPT, GPT-01, and I asked him to generate something related to a large language model have hallucination. And very interestingly, this Eiffel Tower thing was in the picture. So apparently this example has been used many times in the presentations related to hallucination. Okay, so here's a huge table of hallucination examples. We're not going to get into details of them, but yeah, it's just interesting to look at maybe. So for the first task, summarization, is that the first Ebola vaccine was approved in 2021, which is conflicted with the fact year 2014, and China was never mentioned. And we have, so dialogue generation, this is to generate the dialogue from an instruction, which may be hard for to understand from this graph. And we have an open domain dialogue generation, where someone asks, "What do you think about Murray?" And then later on, the model basically had the wrong memory of the speaker said earlier. So that's also part a type of hallucination. Yeah. Now what we care about more is hallucination in large language models. So there are some pretty famous incidents before, like I mentioned. First of all is, I don't know if you guys have tried to ask ChatGPT for the citations. In early stage, when it just came out, it will give you some completely non-existing citations that are just gibberish. They're not real, and they might relate it to some unrelated famous people. So that's part of hallucination in early stage. And if you also use ChatGPT for code explanation and helping guidance, in some period, ChatGPT will also output some incorrect code connecting with the explanation. So these are all hallucinations. And that's why part of the reason why hallucination is so popular and important recently. So why we would have this hallucination in large language models? This is a very complex question and it's still open to be answered, but we do have those guesses. So first, we have pretty noisy training data for most of the large language models, because they all trained based on the source online, and they just kind of scrap all the information from the ops website. So the training data is noisy and might contain inaccurate or conflict fact with each other. And also, huge factor would also could be model design, because all the language models now, all the modern language models store the knowledge parametrically, which means they do not store the language in some external language. They do not store information in some external information base. However, they just store all the information in these parameters in the huge network, where we would have just outdated or like context sensitive generations when it is inferencing. And it's also might be related to decoding strategies, like this top P sampling strategy that has been used quite a lot. So here's a simple explanation of the top P sampling, which you guys probably know more than I do. So this is a sampling strategy. When the language model generates the next token, it will sample from the a possible set of the next words based on the previous output, based on the input, and based on based on all of this information. So this top P sampling will sometimes prioritize diversity because of the design of large language models over factual correctness, where hallucination might be caused. And we also have this mismatch in training and inference. So take the example I mentioned very early. The large language model might know that the capital of France is in Paris, but if you tell it that the capital is actually in Rome, it might just be confused of which is the real capital. And sometimes you do not only want the factually correct answer from the large language model. For example, if you're doing some story rewriting, story continue writing, you want some fantasy setting in the story, like human can fly, human have wings, or dragon exist, and that's when you tell the large language model that these things do exist. However, in the training data, these things do not exist because it's not a real world knowledge, and that's also a mismatch case where hallucination can be easily caused. So we do have a few challenges here to fix the hallucination, to mitigate the hallucination, which one is that for the open-ended task, like dialogue generation, which is when we ask, for example, ChatGPT a question, it will answer us. That is pretty much open-ended task, or the story writing. It's very difficult to constrain the output. It's very difficult just to evaluate if the output is what we want, and it's a very complex process. And also, it's very difficult to reconcile multiple conflicting knowledge sources, which are used to train the large language model online. But we do have a few methods to address the hallucination. First one is very, in the ideal setting, we want better data, but everyone wants better data, and it's really hard. But we can also work on the model design. So here is a very famous method called the retrieval augmented generation, RAG. So this is a very popular model as well in RAG. And in this method, this is basically a framework where we train the model to not only generate the sentence based on the parameters, based on the information stored in parameters, it also train the model to retrieve the information from the external retrieval knowledge base. So yeah, that's basically how it works, and it would help mitigate the hallucination. And we also have instruction fine-tuning, where the model is fine-tuned to execute the specific instructions. So we all have Siris in our iPhone. In early stage of Siri, if you tell Siri to do something, so I can ask Siri, hey Siri, please tell me some this and that, and you can also ask Siri to set an alarm, browse the internet, or like play some music. So these things are instructions, for example, and this whole training process would help mitigating the hallucinations. Yeah. And we also have some inference time techniques involving prompt engineering. So chain of thought reasoning, where in the prompt you will tell the large language model to think step by step. So it's just a prompt engineering technique. Also, we have self-verification mechanisms. We can, when we prompt the large language model, we can ask the model to reflect on the output by inputting sentences like, please reflect on what you said, think about what you, double think if what you said was factually correct. Also, we can train an external model to access and report the confidence when generating the output. And we can also have this multi-agent debate thing to further help mitigating hallucinations. Yeah, so that's everything. This talk is more like a basic introduction of the hallucination, factuality, and faithfulness. And if you have any question, please feel free to ask me. Thank you.